Hi, my name is Garrett Edmondson, and this presentation is aimed at data scientists or people who are already very familiar with R and RStudio and how they can leverage their existing skills and Azure to create full end-to-end solutions in a matter of minutes. This will primarily focus on how, from RStudio, you can deploy and create an Azure web service and an Azure web application to consume that service. So, all that you'll need for this, to replicate this presentation, is an R IDE, a development environment for R. I will be using RStudio, and an Azure subscription. Typically, if you already have an MSDN license, or you can sign up for a free Azure subscription on the Azure website. Um, I want to emphasize this is to help uh, data scientists or people making predictive models, give them the ability to leverage their own existing tools, either R or Python, and be able to operationalize with using those tools in Azure to create a consumable web service and a web application as well. So just going to dive in first. I'm going to show you what the end result looks like. End result in terms of what you start with, and then what will be the final result at the end of this presentation. So to begin with, I'm going to use a publicly available data set. This is from the UC Irvine database here. It has a bunch of data sets, machine learning type data sets. And one of them that is probably very well known is the IRIS data set. And so if you've ever taken a machine learning or a data science type class where they cover things like predictive modeling, you're going to almost always run into the IRIS data set. This particular one has 4 features and then 1 label. And this is a multi-class problem. This particular data set represents a multi-class problem, meaning my label has multiple classes here, and these classes represent different iris species in trying to predict which species it is given the inputs of these 4 features. So, and I want to demonstrate how through Azure you can use RStudio to develop your prediction model, deploy it out to Azure, create a web service, and create a web application connected to that web service, and in a matter of minutes, create something like this, a web application, so it can be viewed on any device, mobile device, laptop, that kind of thing, and it has the four features: sepal length and width, petal length and width, and the user can query your model directly using the web application. So if I change, let's see here, increase the values somewhat, I can submit my query through the web application and I'll get a response back. And this all be created using your existing tool set, namely RStudio in this case. So how do I put this together? Well, it's very easy. If you're already familiar with R, I'm going to be demonstrating how to do that. So this is an R script that I put together very quickly. It has all the basic necessary components for you to be able to generate that same solution as well. I'll be using several packages. I'm not going to go through in great detail this R script. I'm going to assume that you're already very familiar with R, and I'm just going to point out those themes which are unique to developing this type of solution. So to begin with, just to cover real quickly, I'm going to be using a package to grab that data from the UC Irvine's database, that data set, the initial data set, and then I'm going to do a little bit of manipulation on that data, not much. I'm going to use, for my classification problem, I'm going to use a random forest package, which is a great algorithm developed at Berkeley, and then the package that I use to deploy my trained model, random forest model in this case, the package I use to deploy this will be the Azure ML package. It has a GitHub and great documentation. I highly recommend that you read that documentation and become very familiar with it. I'll only be demonstrating a few of the features of that package. There's a lot more you can do with it. The last thing here is our tools. You're going to have to install that as well. So to begin with, I'm going to grab the Iris dataset and make a data frame out of it. I have the URL. So I run that. And so this data frame has 150 rows or observations or cases, however you want to describe it. Unfortunately, as it exists on the UC Irvine website, it doesn't have any column headers. So what I'm going to do is I'm just going to simply add column headers, sepal length, width, petal length, width, etc. to that. And then I'm going to call that the Iris data frame. I'm also going to create another data frame that represents the Iris data frame but without the label. So this will be used, this just has those 4 features. This will be used in terms of schema to determine the input to my function. The function will hold my predictive model. I'll get into the details of that in a few minutes. But that'll make a few things easier for me. So that's what I'll do right now. So now I have my Iris data frame with the column names that I want for the features, and then species for the label. So now that I have my data ready to go, I can create my model. Again, I'm going to use random forest and predict on species, and it would be a classification problem. So I'll just run that. Cool. And I can look at the details of the model if I really want to. At the bottom here, I can look at how many iterations, how many classes were built, all the internal mechanisms of the random forest model. I can plot it out. And then if I zoom on my plot, this tells me about the performance of this particular model, which is very, very good. So I don't need to make any adjustments in that side, in that area. So I'm just going to assume that the model is what you want it to be. Of course, there's a lot of other work going to go into making a predictive model and making it, getting it ready for deployment to production. But I'm going to assume that this model is what we want. So this next section is going to be the section that is important once you have your predictive model ready. You're going to have to create a function. So this function will contain primarily 2 pieces of data. First, of course, it will contain your model. So my model is the predictive model that I trained above. And it'll have an input. So this is going to be my feature input. So I'm just going to have a placeholder there, and then of course it's going to have a response type. And that's going to be respond with with the Iris species that it is. One thing to note here that's important is you also must put any algorithms or packages that you use for the development of your model must be included as part of your function and must be required. So in this case, I used random forest, so random forest. If you do not do this, then when you deploy this out to Azure, the deployment will fail. So make sure you include that. So now I'll create my function, my predict. And there it is, my predict function. And I can test my function locally. I can just use the same data set that I used to create my model to make predictions. And then there's about 150 predictions. There's about 150 observations in the original data set. So as you can see, here is the observation number and then the predictions associated with it. Just to show you that it works, my function works. the next thing to do would be to install, and I kind of explicitly called this out, dev tools. The reason for this is that Azure, the Azure ML package, which I'll get to in a few minutes, once you create your function that contains your model, to deploy that out to Azure, you have to compress the file. So zip it or whatever file format you want to compress it with. And so the DevTools allows you to do that. Otherwise, it will fail. So make sure that you install the DevTools and follow the documentation for the Azure ML package. It's all very well detailed on their website what to do and how to do it, but I've already done it, so I'm just going to load up the packages, the libraries for Azure ML and DevTools. Okay, so now that I have my function ready, I need to deploy it to Azure. And in Azure, there's this idea in machine learning of a workspace. So a workspace is kind of the largest container associated to my subscription that contains all my experiments, all my data models, my trained data models, notes like Juniper notes, and all this kinds of stuff. So I have to be able to tell the deployment, the publish package, where to deploy it, which workspace to deploy it to, my workspace, and then I have to be able to authorize it to make changes, in this case, to publish it out, my function, out to Azure. So I need two pieces of information. They're called the workspace ID and then the authorization key. And this is, if you go to your workspace, this is very easy to obtain. So here's my particular workspace. It doesn't have any web services right now. It has a few experiments, notes, data sets. But if you go to settings, there will be a workspace ID. You just copy that. And then there will be, under authorization tokens, there will be keys that you will need to use. So those are really the only two pieces of information you need to deploy out or publish out this function. So I've just put those in here like so. And there is what's called a workspace function here, which takes as inputs the workspace ID and authorization and grabs some additional information that's needed for the publishing process. So I'll create that. I now have my workspace object, and the publish service function has parameter for the workspace object, which I created, and then I have my function. I tell it what function I use, my predict function from the previously that I created. I'll give my web service a name here. I'll call it the Iris web service. And I can define its inputs. So this is where that Iris inputs that I created previously at the very beginning, that only has the definition for the features, the input features will be the inputs for my web service. So with those small pieces of information, I can then publish out my function as a web service. Give it a few seconds, publish it out to Azure, and there you go. So now I should be able to go to Azure, go up to my web services that was previously empty, and I see my Iris web service. All right, so now my web service is created, which is great. So this contains that function, and it can accept as inputs of values for my features, and then respond back with that. So I can, there's two ways. By default, it's a request response. You can do a batch execution method as well, but you can test it. Just make sure it tests okay. It doesn't matter what values put in there. Just leave the defaults. And it'll take a few seconds to test, but this is just testing to see that it does in fact respond. And in this case it did. So it tests fine. That's great. What I want to show real quick is, now that I have a web service, I can query it a variety of different ways. But the important piece of information is to know where my web service is. This is the HTTP REST endpoint here. So any application or anything like that can be integrated and use my predicted model, my Iris predictive model here, using this endpoint. And it's very well documented. This documentation is automatically generated for me. I have sample request in a JSON format here, and then response, sample response again in a JSON format. I'm not going to go into great details about this. When you create your own, you can look this up. An interesting thing to note that at the bottom, I also have some sample code, which could be very useful. I'm not going to go into great detail here, but C#, Python, R. So this is all the code you would need to embed into your application to query this this service. So, for instance, here's my inputs, automatically generated for me with some default values, and then my response is at the bottom. So, and it's just in this case, it just looks like it's just a little console application that it assumes you're putting it in. You can do the same thing with Python and then R as well. Same thing. Here's some inputs, my four features, and then a response. So I'm not going to go into too much detail, just to say that the web service is there. So an interesting thing and another capability that Azure provides to you is the ability also to create a web application. So now I have my web service sitting out there on Azure. I can actually, using a template, create a web application that automatically connects to my web service. And so how you do that, in Azure, I'm going to go to New, and I'm going to just type in web app, and I'll see a list of some of the available templates there are for web applications. And there's a whole bunch, but I can scroll down to web. I can scroll down, and there is one template application that can be created within a few clicks called Azure ML Request Response Service Web application. Just click Create. I have to give it a few pieces of information, not much. One of them is I'm going to have to create a name for this. This has to be obviously a unique name because this is going to be used as part of the URL for this web application. So I'll call this Iris Demo, and that name's not unique, so let's try Iris Demo 2. Did someone use that? No, no one's used that, so I can use that. Subscription details, I'm going to create a separate resource group just so I can keep track of it and actually delete it when I'm done with it. So I'm going to call this Iris Demo 2. And it doesn't matter where you create it, I'll just pick somewhere a little bit closer. Okay. So that's really the only information I need. I need to give my web application a name, a unique name, and then pick a location, a data center location for that. So I can click Create. And it will take it a few seconds to deploy out my new Azure application. But once that is done, this application will then need to be connected to my web service. And there's just really two pieces of information that my web application will need that I can copy and paste. It'll be the location of my web service, so my web app knows where my web service is. And then if I go back into RStudio, as part of the definition of my web service that I can even query from RStudio, you can get all this information from RStudio as well. There are, let me go up a little bit more. There's these keys. So these keys are authorization keys. So I can use these authorization keys to authorize my web application to be able to query my web service. So let's see. So those will be the two pieces of information I need. Let's see if it is completed, and it looks like it has. Yep, it has deployed successfully my web application. So go into my web application. Here's my web application. If I click on it, I have lots of options and lots of information about this web application. What I'm going to do, I'm not going to go through them all, but just to show you, here is the URL and things like that, the service plan, all that kind of stuff. What I'm going to do is, if I click Browse here, it will automatically, because Azure realizes that it just created a web application, it'll by default take me to a configuration page for this web application. And this configuration page is specific to this type of web application, which expects a web service connection, a web service connection specifically to a machine learning studio web service. And so let's show you what that is. Right now, that is the new URL for my Iris Demo 2 .webservicesites.net, Azure websites.net, and it takes me to the setting page. And so this is where I enter in those two pieces of information: the URL location here for the web service. I can paste that in, and then I can, just to show you, I can get all this information from RStudio as well, just querying it directly, the web service. Here is the authorization code, the authorization key. I copy and paste that in there. Okay, that all looks good. Now, with those two pieces of information, the web application is set up to automatically read in the parameters, in this case the feature inputs that I defined in my function. So, and that's what it's done. Sepal length, sepal width, petal length, petal width. I can make a whole bunch of changes. All I'm going to do is kind of change the max values here to make them more reasonable to the range of values that are available within my data model. So 10 sounds good. 100 would be kind of ridiculous at this point. All right. So that's, I mean, that's all I really need to do. In terms of output, I'm just going to leave one output on. I don't need any other outputs. I'm not producing any graphics or anything like that from my RScript. So that was good. That's all I really need to do. I save this settings page. So this is the settings page where I've defined my web service info and the list of inputs and the output in this case. And then I save my changes, and it'll automatically redirect me. It says success, you've saved the changes, and automatically redirect me to your site. And I can get back to this and change the setting if I ever need to. And then here is my web application, irisdemo2.azurewebsites.net. So I can make a prediction. Let's just do one prediction like this. Or I can type it in. Doesn't really matter. Click submit. And that gives me a prediction. I change my values here, my label values, excuse me, my feature values. Something different, and I should get a different. Let's try something else. So you get the idea. This is a fully functional web service. That can be used by anybody who has a connection to the internet. So hopefully this has been helpful. Hopefully this has been, through this you've been able to understand how Azure can be leveraged with your existing tools your data science tools and to help you create end-to-end solutions as quickly as possible. Usually creating and deploying a production useful predictive model is a very long and involved process that involves procuring hardware and setting up a whole bunch of configurations and things like that. I hope that this demonstrates that doesn't have to be a complicated or long process, that within a few clicks and in a few minutes you can take your predictive model and make it available and consumable to the entire web if you want. So thank you for your time.